Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how they can personally and directly participate in space exploration, science, and astronomy. Or we show you how to navigate space. We're here Friday nights at 9 p.m. Pacific Time, midnight Eastern Time, and 3 p.m. Saturday, Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Thanks so much for joining us. Tonight's topic is Planet 4, and then we'll talk about some of the things that you can see and do in the next week. Jeff, take it away.
Okay, well, Planet 4 is one of the many citizen science projects on Zooniverse. As you might have guessed from the name of the project, it's about Mars, fourth planet. The project's about helping weather and geology scientists by marking photos on the surface of Mars, or of the surface of Mars. Specifically, we're looking for the dark plumes.
And here's the link.
Yep.
And I also added it into the chat for you, Jeff.
Good. And we found out about the dark plumes not too long ago.
Yeah, it was just recently. Boy, is it fascinating, too, how it works.
Yeah. The dark plumes, and you might have seen them on some photos that have circulated recently. But they happen when subsurface carbon dioxide sublimates and brings up dust with it.
Oh, and sublimates, by the way, that's when a solid goes directly into a gas. It does not, turn into a liquid before that.
Yeah, it goes directly to gas, does not pass go.
Right, yeah.
But it brings up the dust with it just because of the force of the air. And the dust deposits around the opening like a small volcano. If there's no wind, then you end up with a roughly circular blob around the opening. And if there is a wind, it leaves a fan in the direction of the wind.
Got it.
Basically, yeah, let's see that. So this is a typical photo that they're going to want you to take a look at. As you can see, can they see my mouse? Yes, they can.
Oh, good. New to us. We're doing this for the first time.
This one's kind of interesting because there's a dark fan here, which means, and then there's a lighter, more diffuse fan out this way from the same source. So it looks like at different times, lower wind here for a longer time, and then high wind in this direction for a shorter time.
I mean, there is weather on Mars,
Yeah.
Definitely seeing clear evidence of that there.
It's not going to blow down a spaceship, but it can pick up dust. The dust is very fine, and it can pick that up. And I heard that the wind on Mars, even at its highest, is kind of like pushing against a person with the tip of your finger. I mean, it's not much wind there.
Well, there's not much atmosphere on Mars to do much with, and there's no bodies of water to get cold and to for the moisture to rise, and it's much more dynamic on Earth than on Mars.
Right. So you got really high winds. I mean, winds that are far faster than anything you see here, but the pressure from them is minuscule.
Oh, I see. Okay. Well, there's nothing really to stop the winds in some areas. It's just all very flat and low. I mean, not everywhere, but yeah.
And it doesn't take much to get that air going because there's not much of it.
Got it. Yeah. So interesting, huh? Oh, and let me check for comments too. Oh, we got one. Alrighty. Oh gosh, thank you so much for joining us, people. This is a good time to.
Yeah, sure.
All right. Thanks, Michael, for being here from Hong Kong, and we're going to talk to Christina for a minute too. Thank you so much, and I know Jared is there with her. Yep. Awesome to have you folks here. If you have any questions, make sure and let us know, and we'll do our best to answer them. Jeff is the expert in this particular case. I have done a little bit of looking at it. For example, they just made it available in French. I guess there was a university student in France who translated the whole page for them. And so if you know French or you're from somewhere that speaks French, you can also participate in this. All right, Seth says something let's see. Am I correct in, I can't read it. Am I correct that the plumes that show in the photo are deposits from the plumes and not active plumes in the process of being emitted? Let me go ahead and share that photo again. And Jeff can talk to that some more, Seth.
Yeah. Oh, hang on. Yeah. Yeah, it is just the deposited. And basically the carbon dioxide basically shoots up, brings dust up with it, and the dust deposits out. I don't suppose the dust would be thick enough even to even see in a photo. I could be wrong. You know, I don't know. I don't know. They might have taken photos of the dust actually, but I haven't seen any in.
Oh, you mean while it's kind of geysering out?
Right. Yeah.
Oh, okay. Because I'm like, but we can see them right there.
Right. No. But
got it. Sorry.
So I don't know if any of these are actually active right now or not.
Okay.
But I haven't seen any in Planet 4 that are obvious, you know, that they're active. So we're just looking at the evidence of the wind, not the wind itself.
Got it.
You know, and so like this one here where it has two different directions, looks like the wind changed direction and intensity at some point during that geyser. And the interesting thing is these little patterns that you see here, the ridge lines, are from the carbon dioxide being heated up underneath the surface and finding a way out. So it finds a little crack and goes, and the crack widens, and it just from the pressure of it, and it raises that up. And so that's why you see all of these patterns here. In fact, these are kind of odd and diffuse patterns from what I see normally, because normally I've seen patterns where they all like go to a central plume. This looks like a very fractured area where you have multiple plumes up. In fact, some of these here, and like this one here, looks like it's in either multiple plumes right next to each other or just a crack and everything's coming up through. Which in itself could be interesting.
Absolutely.
I don't know enough about it to know what that is. In fact, you don't really have to know what it is for this. You just have to identify it, and this is what you do. And this is for a fan, you start off at the origin and you just kind of drag out to here, and then you can use these controls to widen it, and you can move it around pretty easily. And
that's cool.
Yeah, if it's not an obvious plume, like there wasn't a lot of wind when it came out and it's just a blob. In fact, I had one photo where they were all blobs. Oh. But they have a different tool where you just, it makes a circle. In fact, here's one that's was in the process when I took the snapshot, and you see the two dots, and you can basically stretch it in either direction.
So the dust kind of geysers out and just sort of lands in the same spot. There's no wind to take it downstream.
Right. Or minimal wind. As you can see, none of these are truly circular.
Got it.
But it might not be wind. It might be a slope.
Oh, okay. Interesting.
You know, so it could be terrain. And like some of these, I wasn't done marking this. I just found that, hey, I should take one with the actual controls in it. But some of these, like here, is that dust or is that a shadow?
Can you like zoom in on these to see a little bit more clearly what it is?
A little bit, yeah.
Okay.
A little bit.
All right.
It does show up more full screen than it is here, because this is a this is a screenshot that I'm sharing, and so
got it. Okay.
It does show up a lot bigger here, but I can.
So it sounds like you can go into this program and you can play around with things, and okay, there you go. That's much clearer. Here we go. Seth has a question for you.
Sure.
What are the approximate sizes? Can you tell that?
I have no idea. I don't know the size of the photo. And in fact, they might not want us to know, because they might not want us to be guessing about what we should be marking. They might just want to get the raw, this is what it looks like.
That makes sense.
Again, I don't know their reasoning, but my assumption would be that they don't want people making assumptions.
Yeah, that makes sense. That makes a lot of sense.
Just a lot of, this is what I see. Like if you notice this ridge here, I didn't actually mark it because, dang, it's hard to tell, but that could be a valley.
Oh, yeah.
And it could be in deep shadow. And the shadows would be deep because the thin atmosphere wouldn't diffuse the light quite as much. So the shadows on Mars are much more, much deeper and much more crisp than they are here. Not like on the moon where it's a knife edge.
Oh, right,
but,
yeah.
But it is deeper than here.
Yeah, I hadn't thought about that. So there's somewhere in between because there is an atmosphere on Mars, and
minimal,
yeah, very minimal. But unlike the Earth where we have lots of atmosphere, and you're looking through it if you're in orbit.
Mm-hmm.
Okay.
Yeah. So Seth, all we can really see are the relative sizes within the photo. I don't even know necessarily that the photos from one photo to the other are the same pixel size. I would believe that they are, but I don't know.
Oh, that makes sense. Yeah.
I mean, it would make sense that they are the same pixel size, but.
And I was reading, in fact, there's a website, well, the website we showed before, but the Facebook page, and I'll go ahead and share that to the chat. You can actually get onto Facebook and look for them. They were saying that the pictures come from the Mars Reconnaissance Orbiter, and I guess there's two different cameras on the MRO, which they use to take these pictures. So I wonder if they even compare, take two at a time to get sort of a binocular vision. I don't know. I haven't read as much about this as Jeff has, so we'll ask him.
One of the things is that they've got photos of the same location. You'll probably never see them because there's a lot of photos, but they do have photos of the same location at different times.
Okay.
And since this is just dust deposited on the surface, it gets wiped away by the wind really easily. So at different times, this whole thing could have plumes in different directions, could likely have different source points for the plumes too.
Okay.
Because these are pockets of carbon dioxide being heated up, kind of like you get ice underneath snow if you've ever lived, in the northern states, which both of us have.
Somewhere cold.
Yeah. Whereas the light goes through this snow and hits the dark pavement, warms up that layer, then at night it freezes again. But here, we're concerned about the warming up of the layer, and it doesn't liquefy, it gasifies. And since it goes to gas, it takes up a lot more room. And so there's some pressure there, and it just looks for a way out.
Right. Okay, cool. Yeah, you had a little more, right?
No, that was just talking about the different times of year and stuff.
So okay, cool.
So this is just one of the things that are on Zooniverse. I gravitated toward this one because, my second citizen science thing that I did, 10 years ago? Yeah, 10 years ago, was looking for craters on Mars. Doing essentially the same thing, except just drawing circles around craters.
But this is a particular area on Mars, isn't it? Didn't I read something about this near the southern hemisphere or something?
But and I don't know if this is the only thing that they're doing. This is the only thing that I've seen so far on it. It's possible that they've got other image sets looking for other things. I don't know if they're in this project or they'll create a different project.
Okay. But I know it's a brand new project, and they'll give you a percentage done on the website. And we were looking at it's this one's 0. So they're brand new. They're just starting out. Yeah.
0 batches of photos done. Whereas Galaxy Zoo is 97% done. It could, plus or minus a percentage point in there, I think, but it's almost done. And so in this one, you're pretty much starting off fresh and
nice. Get in on the ground floor.
Yeah. And some of them aren't nearly as dark as this one.
Oh, some of the pictures are better contrast?
Yeah, basically not. This is And from the shape of the shadows, I think this one's taken in early morning or late evening.
Oh,
Just because low angle on it. So
okay.
yeah, so I think it's fairly dark in general.
Wow.
Whereas some of the ones that I've seen are much more brightly lit. Okay. If anyone remembers the show Tales from the Dark Side.
And that's where my head went, right there.
Yeah, I know. because I inflicted that show
yeah.
on you.
That's awesome. All right. Anything else you want to share with us, or any questions? Anybody? We really love sharing this with you. And wow, this one's really interesting. I mean, and I had a thought. I think with like Galaxy Zoo, didn't they have at least like 15 different people categorizing the galaxies in that project? Do you think they'll have as many or more or less, or how do you think that's going to play out with?
I'm pretty sure that they're using the same algorithm for this.
Oh, okay.
I mean, it would make sense because like there were some areas where I might mark something and someone else doesn't.
Okay.
And when they see that, basically they get someone who knows what they're doing to look at it.
Okay.
But the less they can get, the less the trained people have to look at, the faster and the more data they can crunch through.
Yeah.
So if everyone finds a certain plume, it goes in the database as, yep, there it is. And that's its rough size, the average the sizes and stuff, and there it is. But if half the people see it, then they have someone look at it and decide what it really is.
Boy, what a great way to get science done, to actually have help from the general population, and it's a fun project. Mm-hmm. And there's lots and lots to do. Apparently, I think they have a lot of photos, right?
Yeah.
All right.
They have a lot. I forget the count. It was high.
Give us a ballpark.
I'm not going to even try.
Thousands, millions, or what are we talking about here?
There's a 3 in there, so it's either 3 million or 300,000.
Oh wow, that is a lot.
I think could be 30,000, but I think it's more digits than that.
Okay, all right. Well, maybe you can come back and put more information in the chat for us. Yeah. How's that?
Yeah, I didn't know that there'd be a test.
I'm just curious.
Yeah.
All right, so I will go ahead and talk about what you can see in the night sky this week, and that's going to be including January 29th tonight to February the 5th. The moon is 17 days old. It will be the last quarter moon on February the 4th. It's kind of quiet this week, but Mars is still very high in the sky, and it's kind of southish as you look, up and then a little bit south. Then I heard that Vesta is going to be easily seen with binoculars, and at a 6.3 magnitude. I think you're gonna definitely want binoculars, and I bet even a telescope would be better.
And a stand.
And a stand, yes.
You're gonna need to zoom in enough that it's gonna bounce all over the place if you don't have a tripod.
Yeah, we learned that lesson. And what you want to do is look in the tail of Leo. Now, you're going to have to wait for it to rise high enough, and so it'll be coming up in the east in the early evening. As we get into February and March, it's going to be easier and easier to find that. Now, I don't know exactly where Vesta will be in February, March, but supposedly this coming month, February, it's going to be something you can easily see. And I don't know how they move compared to like the planets. This is what I just heard about this, so I wanted to make sure you folks heard about that. And
it was much easier to see in the 70s and 80s.
Oh, why is that?
Oh, it's just tooling around the road.
Oh, you mean Vespa, right?
Yeah.
All right. Thanks for sharing, Jeff. Jupiter was in conjunction with the sun today, and not something that's easy to see, but when there is a conjunction like that, either this Jupiter could at times go behind the sun, and then you'll see the atmosphere of the sun compared to Jupiter, or sometimes it can, I guess not in the case of Jupiter, right? It will not transit the sun. That's Mars and Venus.
If Jupiter transits the sun, we're in
big trouble, yes. But things like that happen when, a planet is near the sun, but only transiting for the sun's between here
Or the planets
the
between
planet,
them.
the planet transits between here and the sun, and that's only Mercury and Venus in our
Good.
case.
You got it.
Thanks. Thanks for the cheering on. I appreciate that. On the 30th, the moon is near Regulus, and this isn't something you can see in the night sky, but you can watch it on YouTube on February the 3rd. Wednesday, the weekly Space Hangout is going to be airing again, and that is a regular weekly show. Most of the time, it's like fall into winter into spring. They take off in the summer, so we don't really have weekly Space Hangout during the summertime. And then we're back to February the 5th, which is our next Friday night show. And speaking of which, it's going to get a little more interesting next week. So come back, tune in for way cool stuff next week. It's a pretty good list, and I can't wait to share with you.
Do we have a citizen science?
Yes, it's coming next.
Oh, okay.
So, and just want to make sure you know if you or somebody you know has done something interesting with space exploration or science or astronomy, we would love to share our live with you. We've had several guests so far, and I think we've had a lot of fun. We really enjoy bringing people onto our show and talking about the cool things they have done, especially like if you have done some of these citizen science projects. I think that would be wonderful to talk to you and learn from you what it takes and how to do it. And so next week we've decided that we're going to look into the processing and analyzing images. And unless we have a guest lined up, if we get somebody between now and to talk, we'll delay that to a future episode. But here's the thing: tons and tons and tons of data is out there from various spacecrafts that have toured the solar system, and most of it, much of it, I don't know exactly how much, has not actually been turned into images. So there are a number of ways that people can take that raw data and produce it and come up with images. And I mean, they're even doing things, of course, our computers are more powerful, so they're doing things from many, many years ago and, kind of reprocessing some of the images. And so you can actually get something that was already created into an image and, redo it now, and it's even more clear. It's a better image. It's just fascinating. I've seen a bunch of things about it. So between now and next week, I will make sure to look into it a little bit more and share with you about what I learn. So I think that's a really great one. I mean, to take just this raw data and turn it into a beautiful image that nobody's seen before, because even the NASA scientists haven't. They just have all this information.
Well, and it's not even information yet. It's just data. Yeah. Because there's no meaning to it if it's just sitting on a hard drive.
I guess to me, information and data are pretty much the same thing.
I'm a computer guy there.
Okay, I see there too. Okay. I'm not a computer guy. So, all right. Any other questions from our audience? We're so glad you were here to join us this evening. Really appreciate that. And we want to see you next time in a week. Thanks a lot. Have a good one.
Bye-bye.
Bye.